Today's lesson is on lines. If you need to review a specific topic, just fast forward through the video until you see this slide come up again with the topic you want in bold. Let's start with some definitions. Linear equations, just a fancy way of saying if you graphed it, it was a straight line. The solution set are all the points that line up on a straight line. And of course, we know that slope is the measure of the steepness of a line. So when they talk about rise and run, rise is the vertical distance, run is the horizontal distance. Both of those can be negative if they're going in the negative direction, but as a distance we normally talk about them as being positive. So two lines can have the same rise and run, but if they're in the opposite direction, you'll get opposite slopes. The line on the left, for instance, might have a rise of, let's say, 3 over a run of 5, so it's a slope of 3/5, change in y over change in x. And then the one on the right ends up having a negative rise of -3 and a run of 5, and so it has a slope of -3/5. The slope of the line is simply just that measurement of rise over run. Another way of thinking about it is change in y over change in x. And I've used these symbols, those are deltas, to represent change in other videos. And change in y just means specifically how much y changes from one spot to the next. y2 minus y1 is the algebra equation for change in y. The slope of a vertical line is undefined because it has no change in x, right? So you're dividing by 0. And something we'll talk about later, a horizontal line, right, has no change in y, so its slope equals 0. Sketching the graph of a line that passes through a point P and a point Q. So if we're given 2 points, all we have to do is plot those 2 points on the Cartesian plane, which we've already learned how to do, and connect the dots. Very simple. So sketching a graph is easy. What if we want to come up with the equation of that line, though? Well, the first thing we want to do is find the slope, the change in y over change in x. This is all the gobbledygook involved, but let's look at the picture. I like looking at the picture instead because your rise, as soon as you have your 2 points, your rise is just that distance between this y and this y, right? This distance here. And that's a difference of 4. So my slope being change in y over change in x is just going to be 4. And then my run in red is that distance there where we're going from 1 over 3. That's a distance of 2. So my slope is 2. Now, how did we know that 4 and 2 were both positive? We'll just start with one dot. So let's start with the lower dot. To get to the upper dot along our triangle, we go in a positive direction for the x and a positive direction for the y. So they're both positive. If we had started with the other dot, so let's say we wanted to go in the other direction, and we'll start here with the green one. Well, now when we go from there down, we now have a negative 4, and then we go in this direction, so we have a negative 2 for our x direction, and the negatives cancel, and we still get 2. So the slope is the same in both directions. Just pick a dot and go. Doesn't matter which one you pick. The slope will be the same in both directions. There's their version worked out. That slope of 2 means that every time your x value goes up by 1 unit, your y value goes up by 2 units. So what if your slope was -2. What does that mean? Well, that means every time x goes up by 1 unit, y goes down, right, by 2 units. And then, of course, we could do this all day. If our slope was 3/5, when x goes up by 1, y goes up by 3/5, etc., etc., etc. It's just that simple. Some big key facts about slopes. If we're moving from left to right, lines with positive slopes rise and lines with negative slopes fall. Just means that if we were to look at our xy axes, lines with positive slopes get bigger as you move to the right, right? They get taller, and negative slope lines get smaller, right? Negative lessens as you move to the right. How you want to remember that, it's up to you. As a student, I was told that if you were standing, right, so if you were just standing here, if you fell forward, that's okay. But if you fall backwards, you're going to crack your head open, and that's a negative thing. I think it was a stupid example, but it kind of helped me remember it. I like the idea of, as you walk along the number line, right, we're always going in the positive direction, that positive slopes will give you bigger values. They will increase. Positive, negative slopes will decrease. The greater the absolute value of the slope, the steeper the line is. That just means that whether it's negative or positive, a steeper line comes from a bigger number, whether it's a bigger positive or a bigger negative number, right? So there's our x-axis again, xy axis. Here's one line. There's one that's steeper, so its slope is going to be bigger. Even if we're dealing with negative lines, there's a negative slope, but that one is a steeper negative slope, right? So it's going to be a bigger negative number. So maybe this was -2, but this one was -5. As we said previously, a vertical line, the slope is undefined, and a horizontal line, the slope is 0. Just, don't say that a vertical line has no slope. The slope is undefined. It definitely has a slope, right? Trust me, if you tried to ski down that thing, you would realize very quickly that there is a slope. So it has a slope, it's just undefined. We numerically can't define it because it's being divided by 0.
And that is everything we need to know about slopes.